Figure 1537, two blocks, mass equals 1.8 kilograms and mass equals 10 kilograms, and a spring with a spring constant of 200 newtons per meter are arranged on a horizontal frictionless surface. The coefficient of static friction between the two blocks is 0.40. What amplitude of simple harmonic motion of the spring block system puts the smaller block on the verge of slipping over the larger block? So we'll write down our constants, what we know. So we know that the mass of the small block is equal to 1.8 kilograms. We have the mass of the bigger block is 10 kilograms. And we know our spring constant is 200 newtons per meter. 200 newtons per meter, sorry. 200 newtons per meter. So we're looking for the amplitude of simple harmonic motion that puts the smaller block, so the top block here, on the verge of slipping over the larger block. So the reason why this block doesn't slip is because there is a friction force acting left on the bottom of the small block, opposite the direction that the block wants to move. So the only way this block will move is when the force is bigger than the friction force, the static friction force. So the maximum static friction force that the block can have, so we'll write it, Fs is equal to the coefficient of static friction, 0.04, times Fn. This is the normal force acting on the small block. So if we analyze the small block here, this is a small block. We have the force of gravity acting downwards, Fg. We have Fn acting up, the normal force. And we also have, this is our vertical forces, we also have the friction force acting left and the block's momentum due to the spring moving to the right. So we can see that Fn is equal to the force of gravity. So then Fn is equal to 1.8 times 9.81. 9.81 is equal to 17.658 newtons. So this is what Fn is. That means our maximum static friction force right when the block is about to slide is equal to 0.4 times Fn, which is equal to 7.0632 newtons. So we're looking for when the friction force is 7.06 newtons. So if we analyze the bottom block now, just the horizontal component, so this is the bottom block. Let me just write that. This is M, and I'll just write small m over here. So I'm only going to analyze the horizontal forces in this one. So we have Fk, F from the spring, and then we have the force of friction. So it's acting leftwards on the top block, so it's acting to the right here. Force of static friction. Okay, I just wrote this as Fk from the spring. Okay, so then we're gonna, so we want F spring here to be 7.06 newtons, and we can see that we want the static friction force to be 7.06 newtons, and we want the spring force to be equal but opposite. So we're looking for when the spring force, Fk, is equal to 7.0632 newtons. And when does this occur? So we know that Fk is equal to K times X. So the maximum spring force occurs at the amplitude, xm. Max Fk, spring force. Okay, so then if this is the maximum spring force that can occur before the top block slides, we have Kx at 200 times the amplitude is equal to 7.0632. Then our amplitude is equal to 3532 meters, 3.53 centimeters. So for this sort of problem, the moment when the top block moves is when the static friction is equal to 0.4, the coefficient of friction, times the normal force. That's right when the block is about to move. So you set that at maximum, and then you analyze the bottom block to find the maximum spring force that can occur before the static friction force is equal to that. And then using that maximum spring force, you know the spring constant, you try to find the amplitude because that's when the maximum spring force will occur, and then you can simply solve for the amplitude.